So a few people have asked me about my visual acuity chart, which you can see there. It's based on the mirror, so there's a chair, mirror, wall. This here that controls it, you can see I can just go down like that. It's got a little red pointer as well you can use to move around. And obviously you can change it to letters, symbols. You can see this for pediatrics. There are Lee's pictures as well if you want Lee's. There's E's and C's, etc. And you can obviously have large letters. You can have lines like that, or you can have a chart if you really want, and you're going up and down. But this controller is from Takealot. It's a USB remote. It's about $500. This monitor can be any monitor that you have lying around at home or in your practice. So that's normally cheap, maybe $2,000. If you're lucky, if you've got one at home, it's free. And then the software runs on this. This is called a Raspberry Pi. It's a really cheap little computer. And in here is a little SD card. And so I've adapted some software from Openoptometry online, which runs off this SD card. So you can run the software, you just plug you plug the SD card in, and you plug it into your monitor. And then there's a USB that plugs in from this, and it connects to here, and then you've got a VA chart. So it's a really cheap solution, 600 Rand, plus your monitor. Yeah, I mean, a Raspberry Pi is probably about, depends where you get them, 1,200, 1,300 Rand. Some of the quotes I got for charts were much closer to about, I don't know, probably closer to 30 grand.
So what you need to build something like this. So this is firstly a Raspberry Pi. This is on Takealot. I'll put a link in the description below. But essentially this is a small PC that runs it. It's got a USB-C. This is what powers it. It's got an HDMI, that you have an HDMI out to your monitor. USB port where you plug the controller in, and then an SD card slot, which is over here, where you plug your little SD card in to, which runs the software. You'll need a remote of some description. So this is the remote that I've used, and you know, there's numbers and there's letters. This is essentially a keyboard, and the software runs off these keyboards. It's got up and down arrows, etc., which is relatively self-explanatory. And then you'll need an SD card. So, I mean, you only really need a 4 GB SD card. Those actually aren't that common to get nowadays. So, I mean, you can pick up a 16 gig SD card relatively cheap. If you buy them in bulk, you can get like a set of 10 even cheaper if you're running multiple monitors. Again, I'll put all the links in the descriptions for these ones, but you can buy any SD card will do. Then to put the software on, you'll need something like Etcher. I'll put the link to download the software. If you download and install the software, I'll show you what that looks like. This is what the software looks like. You will choose from a file, and you go into your PC to find that ISO file. You select the SD card, that you connect to USB of your computer, and you click flash, and then it'll write that ISO file to that SD card. And then all you do is you take this SD card and you plug it into your Raspberry Pi. You power it up with a USB-C cable. Often the monitors have USB, so you can just plug it straight from your monitor into there to power it from the monitor. And then you plug the SD card, the USB. There's a USB that comes with this that just gets plugged into one of the USB ports, and then you power it up, and it should run. Some people wanted to know kind of what are the functionality of it. To test out the functionality, it's quite easy. You just go to Openoptometry online. You can see there's a URL there, but I'll post a URL in the description as well. And then you can test the functionality. So you'll see that, for example, on Snellen Vision Acuity here, there's different options. The numbers on your keyboard or on the remote will change it from a letter to pictures, to C's to E's, but I've added shortcuts for those. But you can see if you use your keyboard, the numbers 1 to 7, change that. So if I go back to letters, and then the letters Q, W, E, R, T on your keyboard will change it from a line to 5 lines to 15 lines, depending on what you want. So that's Snellen. There's a whole lot of other things in here. There's diagrams, for example, for explaining things. I guess you could customize these images to anything you wanted, but it has those. It also has your duochrome test. Where is that hiding? Here we go, duochrome. And these are your buttons on your keyboard. So you've got diagrams, cartoons, text, duochrome, astigmatism tests. It also even has contrast. So you can have contrast. You can make it line, let's say a line, and as you got smaller lines, you'll see the contrast diminishes. So you can also test contrast. Let me go increase the contrast again. So there's a variety of factors. You can play around and see all the different optotypes and all the different features, and you can fiddle with this online at your computer. Just plug it in. It's got the options to mirror. So if you are looking in a mirror, you can just set the mirror to have it mirror. And I think the most important thing to know is just how to calibrate it correctly. So in the bottom corner here, you can see some numbers. So there's two things that you need to measure. So the one is the distance in meter that your patient is standing from your chart. So that could be, if it's 3 meters, let me just put 3 in there. You'll see that the numbers get smaller, obviously. And then the other thing is just then once you've set this to 3 meters, you just measure this line. So the distance from there to there, and you input that value over there. And then it will make an adjustment. It knows what's the size of your monitor, how far the distance is, and you've measured the size of that line on your ruler on your screen, and then it will do an adjustment for you, and then it'll work. Obviously, if you're running this online, you have to be connected to the internet to do that. But if it's on the Raspberry Pi, the way around that is also relatively simple, because all these settings are set up in the URL over here. And so once you've set this up however you want, you'll see in the URL at the top, which I'm going to show you now. So in the URL, you can see in this top line here is a bunch of text. I'm gonna copy this. Just to show you a bit closer what actually is going on there. So I've copied that URL just to make it bigger, and you can see in this URL it says it's got units equals centimeters, distance equals 3. So that's the distance is 3 and the size of the line is 1. So it's saved those values, and then you just adjust the URL that's on your Raspberry Pi to match this, and any of the other settings. It also saves it into this code. For example, whether you want it mirrored, or so if you mirror, this will be true, but you just copy the URL from the website, or just adjust your URL in your Raspberry Pi. So once you've put the ISO, you've written the ISO using Etcher, so you've used Etcher to put it onto the Raspberry Pi. Just go into the HTML file and you can make these adjustments depending on what the distance of your room is, and you can calibrate it accordingly. So I've put my SD card on my computer. I've opened up the folder, the boot folder, where is on the SD card, and you can see here's a file called full page OS, and so this is the URL. If I double click on that, I'll just bring up that URL. Hopefully you can see it. I'll try and make it a bit bigger. There it is there. And so this will be the HTML file on that'll run off, and you can just see all these settings. You can see mirror is set to true. You can see distance is set to 9.3 because that's the distance in my room, and the line size at that distance was 3 centimeters. And so this is my setup. Obviously this will depend upon your room, but I just wanted to show you would just go in here, you would select that, edit it, and then save that file, and then that will save that file on your SD card here, and then when it boots up it'll have the right settings. Another small things, obviously there's lots you can go into with this, but one of the things is you could change the splash page just to a PNG file. This is our logo, but if you changed it, meant when it booted up it would show your logo, but that's neither here nor there. But yeah, that's how you set up a VA chart using Openoptometry, Raspberry Pi, and yeah, I hope it's useful. Definitely, I've used it for about a year now, and it's been very robust and pretty bug-free. And I hope you found it useful in your practice.